In this video, we'll learn how to draw and interpret skeletal line drawings. Although Lewis structures are useful and show the full structure of an organic molecule, they're fairly time-consuming to draw, and many of the features of these structures, like CH bonds, occur over and over again in organic structures. So instead of drawing a full Lewis structure, in organic chemistry, we most often use skeletal line drawings, and these are almost an abbreviated version of a Lewis structure. In a skeletal line drawing, the lone pairs and hydrogen atoms are omitted from the drawing, and the carbon-carbon bonds are depicted as lines. In this form, a carbon atom is simply a vertex or a corner between two lines. All other atoms, nitrogen, oxygen, sulfur, chlorine, must be drawn in. As an example, if we have the condensed formula shown on top here, then the full Lewis structure would look as shown. In the skeletal line drawing, the hydrogen atoms and the lone pairs are omitted. And the bonds to carbon will simply be drawn as a line, and that will give us a much simpler form or depiction of the same structure. Okay, let's try one. Pause your video and convert the condensed structure below to a skeletal line drawing. And I should caution you that at this stage, you're not expected to go straight from the condensed structure to the line drawing. It's much more likely that right now, and until you get comfortable with these, that you'll want to draw the Lewis structure first, and then use that to make your skeletal line drawing. Okay, welcome back. When I convert this condensed formula into a Lewis structure, I work from left to right, and I just draw out each CH3 or CH2 group. The parentheses with the chlorine in them indicate that the chlorine atom is bound to the CH group. We read these from left to right. Now this isn't a full Lewis structure because the hydrogens aren't fully drawn out. So we can draw the Lewis structure here as well. And now to convert this to a skeletal line drawing, each hydrogen atom will be omitted, and the carbon-carbon bonds will simply be indicated as lines. Don't forget to count the first point as a carbon, and then each vertex, and then the end of the chain as additional carbons. Okay, now we need to draw in the chlorine. It's on the 5th carbon over, so we simply indicate that with a bond from carbon 5 to the chlorine. The hydrogen atoms are all implied in this structure, and it can be much easier to look at and identify what we have that's not just a CH bond, what we have that's reactive or is a functional group, as we'll see later. Finally, we'll end by drawing the skeletal line drawing for C2H6O. In our last video, we drew a Lewis structure for this formula, so we can use that as our starting point here. Remember that the hydrogens on carbon are omitted, but hydrogens on all other atoms must be included. Our 2 carbons will simply become a line with a line to the oxygen. And here the endpoint and the vertex indicate the 2 carbons. If you want to try the line drawing of the other Lewis structure we came up with, in this case, all of the hydrogens are on carbons, so they will all be omitted. Then the oxygen is in the center and is bound to a carbon, so the carbon-oxygen bonds are indicated with lines. And the end of each line indicates a carbon.